Hello, my name is Jeffrey Bryan, and I want to go over the object-oriented software engineering video that we went over for Lecture 7. So pretty much we're transitioning from the functional requirements and the user cases and translating that into code. But before we do coding, we have to map out what we want to code before. So pretty much in this video we talked about why do we design before we code. So from there we talked about that before coding, or if you code before actually designing it, it goes into a lot of redesign and it's hard to collaborate with the group because everyone's doing their own thing. So to avoid all that, to design, you avoid the coding incorrect solutions, you can increase ability of others to code in parallel, and also you can create interfaces, which is full of parameters, method headers, and doesn't require any implementation. So the goal moving forward is to turn the high-level descriptions, which is our user stories and use cases, into software design. So the steps from doing that is using our use cases and map them into object-oriented constructs. So the nouns in our use cases are the classes, the adjectives transitions into the variables, and the active verbs goes into the methods. So when we discover such as the adjectives, we don't want to use the data types yet. We just want to figure out what they fall into: classes, variables, and methods. And then from there, we went into something called UML, which is Unified Modeling Language. Unified Modeling Language is basically a class diagram that describes how classes and relationships are and determines how classes interact with each other, which pretty much is an interface. So a UML is designed by class name and then has instance variables, which can be public or private, and then it has class methods, which is parameters and the return type. So the common types of relationships between the classes are association, which can be looked at by multiplicity, which is like a flight. A flight can have more than one plane into it. And then there's a type of associations, such as aggregation or composition. And then other areas is inheritance and realization. So when I searched up UML to see if companies are still using that, I researched and seen that some companies don't require the knowledge of UML. It's not really something that they look for, but it's definitely useful to know. And some companies have a love-hate relationship because UML can be time-consuming. And like I said in the video, only one person pretty much focuses on the software design of the coding, as the senior software engineer or the software designer. So it's pretty much like a love-hate relationship. Personally, for me, I can see the benefits of doing UML and not doing UML. UML can be time-consuming, but it does offer benefits at the end of the confusion and already having things mapped out, which would have coding implemented very easily because each class just depends on each other, and once you have one class done, it'd be easier to finish another class, and you can code in parallel instead of trying to figure out how to merge these two classes together. So honestly, I think UML would be very useful when it comes to our app products, and we'll see how that will work out when we start coding. And that is my video. Thank you.